Hello everyone, I'm Dr. Vivek Saxena. In this topic, we will cover the star-delta transformation. In the star-delta transformation, by using this transformation, we can convert three star-connected resistances into three delta-connected resistances. How it is possible to convert such type of resistance combination? Firstly, we have to drive the star-delta transformation derivation. To understand this topic, firstly, this one is the star delta transformation. Firstly, we will convert delta to star conversion. It means we can convert the delta connected resistances into star connected resistances, or you can say we will find the value of star connected resistances in terms of delta connected resistances. As you can see, right hand side of this screen, these are the three resistances that are connected in star, and in this diagram, you can see the three resistances are connected in delta. For A, B, C, these are the points of a circuit. RA, RB, RC are the resistances that are forming the star combination, and R1, R2, R3 are the resistances that are forming the delta combination. In this derivation, we will convert the star connected and delta connected resistances in terms of star connected resistances. For find the expression or derivation of this topic, firstly, we have to consider that if we are converting three resistances star into delta, or converting the delta resistances into star, then this condition must be satisfied that the equivalent resistance between any two similar terminals of star or delta connection must be same. It means the equivalent resistance between A and B terminals will be equal to the equivalent resistance between A and B terminals of delta combination. For solving this, for finding the expression of star connected resistances in terms of delta connected resistance, we will firstly consider this assumption that must be satisfied for conversion star to delta or delta to star. As you can see, firstly, we will write the expression here. RAB R equivalent resistance between A and B terminals of star connected resistance. It would be what? RAB, it would be RA plus RB. RC is the open circuit resistance. That's why we will not consider in this expression. It would be RAB star, it would be RA plus RB. In delta connected resistances, RA would be R1, R2 and R3 would be in parallel, and the combination of R2 and R3 will be in parallel of the R1 resistance. It means R1 will be in parallel of R2 plus R3. After solving this expression, RA plus RB, it would be equal to R1 into R2, R1 into R3 divided by R1 plus R2 plus R3. This one is our expression number 1. Similarly, we can find the equivalent resistance B to C terminal and B to C terminal in the star and delta connected resistances, and the next expression would be equivalent resistance between C and A terminals. In our next slide, you can see here the equivalent resistance between B and C terminals of star. It would be equal to RB plus RC, because RA resistance will act as a open circuit if we are finding the resistance in between B and C terminals. Similarly, for equivalent resistance B and C terminals of delta connected resistances, it would be equal to R1 and R3 will be in the series combination. After that, the equivalent resistance of R1 plus R3, it would be equal, it would be in parallel of R2 resistance. It means R2 would be parallel in R1 plus R3 if we are finding the equivalent resistance between B and C terminal. As you can see, after simplifying the value of equation number 2, RB plus RC. This one is the equivalent resistance of B and C terminals in star combination. Similarly, the equivalent resistance between B and C terminals of delta combination, it would be equal to R2 in parallel of R1 plus R3. The expression would be RB plus RC is equal to R2 R3 plus R1 R2 divided by R1 plus R2 plus R3. This one is our equation number 2. In equation number C3, we have find the equivalent resistance between C and A terminals. In star combination, the equivalent resistance between C and A terminals, it would be equal to RC plus RA. And in delta combination, equivalent resistance between C and A terminals, it would be equal to R1 plus R2 in parallel of R3. It means the resultant would be RC plus RA is equal to R3 R1 plus R2 R3 divided by R1 plus R2 plus R3. This one is the equivalent. These are the three expression that would help us to find the expression of RA, RB and RC in terms of R1, R2 and R3. R1, R2 and R3 are the resistances of delta combination, and RA, RB, RC are the resistances of star combination. After adding equation 1, 2 and 3, you will get the value of RA plus RB plus RC is equal to R1 R2 plus R2 R3 plus R3 R1 divided by R1 plus R2 plus R3. This one is the equation number 4. For finding the value of RA, RB and RC in terms of R1, R2 and R3, we have to do that. We have to subtract equation number 1 from equation number 4. After that, equation number 2 from equation number 4 and equation number 3 from equation number 4. This process we have to do separately. After subtracting equation number 1 from equation number 4, then we will get the value of RC, because in equation number 1, the left hand side was the RA plus RV. It means if we are subtracting RA plus RV from equation number 4, then the remaining term would be RC. Now, the final expression of RC is equal to R2 R3 divided by R1 plus R2 plus R3. Similarly, after subtracting equation number 2 from equation number 4, you can see here, if we are subtracting RB plus RC from RA plus RB plus RC, then the remaining term would be RA. RA would be R1 into R3 divided by R1 plus R2 plus R3. Now, equation number 3, we are subtracting equation number 3 from equation number 4. Then the remaining term of the left hand side would be RB. The value of RB would be R1 into R2 divided by R1 plus R2 plus R3. So these are the final expression for the star connected resistances in terms of delta connected resistances. If we know the value of R1, R2, R3, then we can, by using these formulas, we can easily find the value of RA, RB and RC. Now we will move forward to the next step, that is star to delta conversion. From our previous slide, we have written here the results RA, RB, RC in terms of R1, R2 and R3. Now, in this section, we will try to find out the value of delta connected resistances in terms of star connected resistances. It means we already know the value of RA, RB, R3. We have to find the value of R1, R2, R3. Now, for finding the final value of R1, R2, R3 in terms of RA, RB, RC, what we have to do, we will multiply RA into RB. After that, RB to RC. After that, RC to RA, and then add all the results. It means the left hand side would be RA into RB plus RB into RC plus RC into RA. The expression would be RA-RB plus RB-RC plus RC-RA. It would be equal to R1, R2, R3 in bracket R1 plus R2 plus R3 divided by R1 plus R2 plus R3 whole square. Then the square terms is neglected, plus R1 plus R2 plus R3 from numerator and denominator of this expression. Then the final expression would be RA-RB plus RB-RC plus RC-RA is equal to R1, R2, R3 divided by R1 plus R2 plus R3. This one is our equation number 8. For finding the value of R1, R2, R3 in terms of RA, RB, RC, what we have to do, we have to divide equation number 5, we have to divide equation number 8 by equation number 5. After that, equation number 8 is divided by equation number 6. After that, equation number 8 is divided by equation number 7. Then we will get these results. R1 is equal to RARB plus RBRC plus RCRA divided by RC. R2 is equal to RARB plus RBRC plus RCRA divided by RA. And R3 is equal to RARB plus RBRC plus RCRA divided by RB. These are the expression of delta connected resistances in terms of star connected resistances. As you can see here, R1, R2 and R3 are the delta connected resistances, and RA, RB, RC are the star connected resistances. By using these formulas, we can easily convert the delta connected star connected resistances in terms of into delta connected resistance, or you can say the value in the star connected resistances in terms of star connected resistances. These are our this is our star delta transformation. These are the textbooks for the references purpose. Thank you.